So I'd better explain myself. Why is this a DIY install, yet there's two clearly professional electricians on the roof? Well, to avoid small things like house fires and getting some of that sweet, sweet export payment, this ended up being the best route for us. That said, the system is my own design, as far as it can be. So how did we tame the two electricians? Well, it turns out if you call enough people, especially some people that you've worked with on projects before, and say things like, hey, we'd like to install a DIY solar system, and I'd like your liability and certificates to sign it off, you're often met with the response of, but eventually somebody does pick up the phone and listen, and it turns out that we had a great opportunity with Jamie and Tom. They were looking to train up two junior members of staff who hadn't worked on this particular type of equipment before, and we had a roof that was going to offer all three aspects of common solar roof install in the UK. So the steep roof had vertical rails on it, the shallow roof had horizontal rails on it, and the flat roof had a ballasted system. So it was a really nice opportunity for us all to work together and not expose paying customers to basically being guinea pigs for training up new members of staff on new types of equipment and install practices. I did look at some other routes to do this as a purely DIY install. In hindsight, I'm really glad I didn't, because it was mostly a labour problem. If you lived in the house and you were happy with having scaffolding up for multiple weeks, you could just chip away at this and probably do this mostly on your own, perhaps with a second person to lift the panels on the roof. But for me, driving down to my dad to help him do it just wasn't feasible, and with the help we got from Jamie and Tom, we really could crack along on the project. The other thing is the money side of it, right? If you don't have the paperwork, you can't get paid for your export payments. And there are maybe ways going via the council, getting building control to give you a Part P, and that's going to cost money, and it's not entirely transparent how that process works until you're right in it. The same goes with the MSC alternative FlexiOrb. You're probably not going to get anywhere unless you're professionally registered. Octopus does certify systems that aren't under the MCS umbrella, but again, it's not entirely clear from Octopus to me what criteria we had to meet. So all things considered, just like scary high voltage electricity, we took the path of least resistance to actually get the project going, and still miraculously managed to keep the costs way down. Okay, it's the night before, trying to get organised. So we've got stuff for marking out, chalk line, duct tape, hammers and pry bars and things for lifting tiles, stuff for cutting the tiles. Then we've got the first few roof hooks that we'll get our, figured out with. The guns and drivers, you need a 13mm socket, a 5mm Allen key, and then a T30 Torx bit for the roof screws that we've gone with. Yours might be different. And then the other thing I've got, big innovation, because it might be wet tomorrow, is a big box with a lid so that I can keep clothes and tools and things dry. I thought I would answer the question of how I designed the rails and got the right number of roof hooks and all that kind of stuff. I guess first things first, I'm just some guy on the internet you've never met. Don't take my advice, do your own homework, read the standards. I don't want to be responsible for your solar panels ending up in your garden after a windy day. But who would love to take responsibility, at least partially for that, is Renusol. They're a nice company from Germany. They sell rails and solar panel mounting systems, and they've got this nice online configurator. You just make an account, make a new project, and the first thing you've got to do is pick where your system is going to be. So let's just pick a random building in Lincoln. How about this one? And then you need to give it a bunch of information about how high it is above sea level, what the snow load is going to be like, what the wind speeds are going to be like, and that all comes from the standards. In fact, if you open up the map, you can see a copy of the standard map from this European norm. You can see here for our location in Lincoln, we are in snow load zone 3. But likewise, if we were further north, you would have a much higher snow load. And then the same goes for the wind. If we just change that, the further north you go, the more windy you are, the higher the typical wind speed is, or the typical extreme wind speed. And it's putting that into the calculations, right? The more snow there is on the roof, the more weight there is on the rails, the more load there is on the roof, and it needs to know all of that to make sure that the thing doesn't blow off. So you put that all in there. You do need to tell it some other things about your surroundings. For example, the type of wind speed and wind type that you would get in a city versus at the seaside could be really different. Maybe if you're in the city and you're funneled between two skyscrapers, you're going to be in a very windy location. Or if you're at the seaside, right next to a cliff, you're going to be in a really windy location. The other thing is the factor of safety that the standard should take into account. This is this failure class consequence. So presumably, if you were putting a system on an agricultural building and it were to come off the roof and land in a field, or, God forbid, on a cow, poor cow, that is a very different set of circumstances to say if you were putting it on a school and it blew off the roof and killed a toddler. So you put that in there, and it will change the factor of safety in the calculations, I believe. Next thing is the topography, a bit like the seaside versus city. If your system is right on the edge of a hill or a cliff face, you're going to have a very different type of wind experienced, and it needs to know that to do the calculation according to the standard. So in this case, we are not. Next thing, obviously, we need to know what the roof is. So is it a flat roof? Is it a gabled roof? I'll just show quickly the gable roof type. You can enter the roof form in manually and do all sorts of complicated stuff with obstructions, what kind of chimneys and things you have. But just for this demo, let's just do a standard 6 meter by 5 meter roof with a 35-degree pitch and a 2-story building. So that's something like 7.5 meters. A lot of this you can measure inside the roof in the attic space. Just get up there with a tape measure, take the measurements, count the number of bays and the number of trusses, and that will save you a lot of time and a lot of hassle getting up on the roof. The other thing that you can do is take pictures from a distance away and then put it in a CAD package or just a viewer on your computer and take measurements. I've even seen people counting tiles. You should be able to find out the pitch of your tiles. So if you can count 20 tiles from eaves to ridge, you actually know how wide the roof is and stuff like that. Okay, so let's move along here. This is going to be a pan tile roof, quite common in my area, and you do need to give a good estimate as to the batten spacing. Again, this is something that you can measure inside the roof by feeling around or looking up the standard spacings for the tiles that you're going to buy. And the reason that you need to know the batten spacing is because if we look at this little picture here from our friends at greathome.co.uk, you can only ever put a hook basically on top of a batten, right? It's going to go on that batten and then hook around this tile, and that hook can only ever be on top of this batten, or this batten. You can't really have the hook in between two battens. So knowing that spacing is what's driving where your panel system is going to start and stop. Similarly with the trusses, right? You can only ever put a hook screwed into a truss. You can't, unless you get out extra bits of wood and do complicated stuff, put them in between trusses. So you need to know where your first truss starts and the spacing between them. Okay, so we put that information in. Standard rafter roof, and then again you can get all these measurements from the loft. So in my case it was 14 inches on centre, roughly. Another thing that's worth checking, don't just measure one bay and assume that that's the same. Maybe the roofers were drunk that day. Turns out mine were a little bit tipsy because all of my truss measurements were more or less 14 inches, but some of them ended up being as much as an inch, inch and a half out, and just worth being aware of that in case your design may not fit. The other thing that you need to do is, as I said earlier, find out where your first truss is going to be. It seems like they put the gables up, and then they'll just work from one end to another with that standard measurement. They don't evenly space them all of the time. So you might find that your first or last truss is not exactly the same as all the others, and that's going to impact again where your panels can go on the roof. So I'll show that in a second by making this a bit more extreme. Finally, how thick is the rafter, right? If it doesn't know how thick the wood is, it can't calculate the loads and therefore the stress on that wood. Right, so we're in, we just need to tell it what solar panels we're going to use so it knows how big they are. In this case, we were using JA solar panels, and that was the 455 version. So I'm going to select that there. And really, it's just so that it knows the weight and the length and width. And then you've got two choices. I use the Renusol Plus system, so that's a standard on-roof rail system. If you did want to take all the tiles off or you're building a brand new roof, you might be looking at this Renusol, so an in-roof system. Then we need to tell it which way up we're putting the solar panels on. So for me, on the steep roof, they were portrait. It'll make a recommendation as to the type of roof hook based on the roof covering material that you selected. You get different roof hooks for slate and plain tiles and so on. But with pan tiles, there's basically only one option, and that's this new adjustable one. And then we need to tell it what we're doing in terms of rails. So you can have a cross rail system where you've got both vertical and horizontal rails. Generally you see people mostly using a single layer. We're going to have them horizontal in this case because we've got portrait panels, and depending on what kind of loads you're expecting, you can either have the thick rails or the skinny rails. And it's worth having a think about whether you want the fixations to be hidden under the modules. In my case I did, because I didn't want any visible hooks, and I did want alternating hooks just to spread the load out a bit. This caught me out at first, being able to select the rail length. So, maybe you don't want to have 6 meter rail shipped to your house. Maybe you only can buy a certain size. You just need to tell the calculator what type of rails you want it to take into account, and it will base the design on that accordingly. Rest of this, very self-explanatory. Worth bearing in mind that Renusol's manual says that you shouldn't have a cantilever more than 300 millimeters. And I think that's about all you need to know. Basic stuff here. We wanted black clamps because we had black panels, and silver end caps because we had silver rails. Okay, so it's drawn me a virtual view of the roof. The battens are in grey, and the trusses are in this rather lovely salmon colour here, going up and down. Then I need to put in here where I want my solar panels to be. So I want them to be roughly in the middle of the roof. So that's going to be about 700 from there, and maybe about 550 from the left. The other thing that you can do is put in here the sort of, guidance should be 300 millimeters from the edge of the roof, and it will put the solar panels on. Now, there's a small problem with this. You can see that we're not really very symmetrical about the trusses, and we're sort of barely over this one. So what you might then go back and do is just nudge it a bit further to the right by increasing the distance you want the panels to be from the left. And we're getting better there. So still a little bit far off. Maybe we'll just nudge it another 50 mil. You can obviously play with this to your heart's content. And what we should have now is an array of panels that is symmetrical on the trusses, and it's about 2 trusses in from each side. And that thing I said earlier about how the first truss isn't always exactly a bay's length from the edge, you can see that happening here. So that's why that's important, right? If that was a really standard distance, it would be fine, but if it was something a bit weird, it could throw your whole design off. So getting near the end now, just going to press the calculation button. Based on the wind and snow loads that you put in earlier, it's going to give you a suction load. So how much is the wind trying to suck the panels off the roof or push them onto the roof? And again, if they're covered in snow, how much is that extra weight plus any wind speed trying to push them into the roof and putting stress on your trusses? And then our static analysis all came back here green. You can see that it thinks that the fasteners are only being used to 40% of their capacitor. Also the same for the rails and the clamps. Again, you need to check all this yourself, right? Do some simple beam bending calculations, make sure you're happy, read the standards. But this Renusol calculator was really helpful in this process. And then the final thing you do is you just go to your parts list, and you can see that it will generate for you a list of everything that you need to buy. So you can send that off to your wholesaler, and then they will tell you all the bits and bobs that you need to buy. And finally, Renusol were actually really helpful. So if you do have questions, just email them. Email their support line with your project ID and they'll get back to you and give you some help. Okay, so back to some action. Not so fast. Just a quick one before we get back to the action. The final thing you can do is download a full report. So you get the layout plans showing you where all your hooks should go. You get the bill of materials that you can send to the wholesaler. And then finally, if you keep going, you also get a full explanation of all the various calculations and how they did them and what numbers they took into account. So if you want to, you can go through it and check everything is hunky-dory. Okay, now back to the action. One of the problems that we've had today is figuring out the right torque for everything so that we don't snap bolts. I managed to get from the installation instructions the torque settings for the nuts here and the bolts on there. But what we weren't sure about was the torque settings for these screws that go into the roof hooks. And obviously they've got to be stainless so they don't rust. But because they are stainless, they're quite soft and not especially strong. Now, you would think that a small impact driver like that couldn't shear those, but it turns out a small impact driver like that can easily shear these screws off. And what I'm going to do is just test running it in with the drill gun, but on a, one of these random torque settings, and then double check that with an actual torque wrench. So the first one with the impact gun. And then we'll do the other one with the screw gun. I've not gone all the way down on these, and in fact what we were doing today after we realised that this might be a problem was checking every single one with this torque wrench here. Very difficult to do one-handed. So what I'm trying to figure out now is, this is obviously not calibrated, but what number on here is close to the 5 Newton meters that we need for this specific screw. So it's the exact same impact driver, except this one with the 1.5 amp hour battery and this one with the 5 amp hour battery. And that one, if you really go at it, will shear a screw in half. So you do need to be careful. You should be tightening them up under tight and then finishing them off with an actual torque wrench. And if you contact the screw manufacturer, they will give you a recommended torque for the screw. So that's a look at kind of virtual roof we've got here. This is your roof truss, and then you can imagine that the first pan tile slides in underneath the roof hook, and then the second pan tile drops down and goes into this gap here. And you will probably have to grind off a little bit out of the back of the tile to get the clearance that you need. So it's the end of day one. I'm just in the loft trying to check that all the screws are actually in the joists and we didn't miss any joists. Tools dropped 0, solar panels mounted 1. Feet put through the roof, thanks Jamie, 1. And we got all the rails on, I'll show you that now.